This isn't a story about dinosaurs. It's a story about air, ice, and fire deciding who gets to keep breathing. A mile of ice once sealed the equator. Lava fields grew larger than 3 states put together and burned for 2 million years straight. One of these collapses came within a hair of erasing life on Earth for good. The day the sky fell. The dinosaur pages in an old-school textbook never really explained why they disappeared this fast. Around 66 million years ago, at the end of the Cretaceous period, an asteroid roughly the size of a small city crossed into Earth's atmosphere over what is now the Yucatan Peninsula in Mexico. The impact released energy far beyond anything a volcano or earthquake could produce, triggering wildfires across entire continents, then blocking the sun with dust for months. So photosynthesis stalled and food chains collapsed from the bottom up. The crater it carved stretches about 110 miles across, roughly a 2-hour drive from one rim to the other. Stand at that rim today, buried under younger rock, and you are standing at the exact place where 3 out of every 4 species on the planet lost their future in a single afternoon. Non-avian dinosaurs went first. Scientists argued over the cause for decades until geologists found a thin gray layer of iridium, a metal rare on Earth but common in asteroids, sitting in rock all over the planet at exactly this age. One layer of dust settled the argument. The planet freezes solid. Long before anything with a face existed to notice, Earth tried on a different kind of apocalypse. Around 650 million years ago, deep in the cryogenian period, glaciers crept from the poles all the way to the equator, wrapping the entire planet in ice a mile or more thick, a slab taller than any skyscraper you've ever stood beside. Ice reflects sunlight back into space instead of absorbing it, so the more the planet froze, the colder it got, a runaway feedback loop with almost nothing left to stop it. If you stood on that ice at the equator, you would be standing where a beach should be, staring at a horizon of white in every direction, with no plant, no animal, no sound. Volcanoes kept erupting underneath all that ice regardless, slowly pumping carbon dioxide into the air with nowhere for it to escape. That buildup is what finally cracked the freeze, tipping the planet into a heat spike violent enough to melt it all in a geological blink. For decades, geologists who found glacial scars in tropical rock assumed those rocks had simply drifted there from somewhere colder. Only when paleomagnetic readings pinned the rock's original position to the equator itself did anyone believe the planet had frozen edge to edge. The ocean runs out of breath. Nearly every complex animal alive during the Ordovician period lived in the sea, packed into shallow reefs spread across a warm global ocean. Around 445 million years ago, near the end of that period, something changed on land, not in the water. Some scientists believe the trigger was small, the first primitive plants creeping onto land and pulling carbon dioxide out of the air as their roots broke down rock. That cooling froze the southern supercontinent solid, and so much of the ocean locked into that ice that sea levels dropped roughly 300 feet, enough to drain water off coastlines the height of a 30-story building and strand the shallow reefs most marine life depended on. Watch that coastline shrink, and the waterline retreats day by day, leaving reef life nowhere shallow left to go. Then, just as species began recovering, the glaciers melted back, and a second blow landed in reverse. Oxygen-starved water spreading through the deep ocean, suffocating whatever survived the drought. Together, the two pulses erased roughly 4 out of every 5 species in the sea. For a mass extinction this severe, the cause turns out to be almost embarrassingly small. The first plants that would eventually make Earth livable for everything on land nearly emptied the ocean first. When forests choked the ocean. The first real forests on Earth were also its first weapon. In the late Devonian period, around 372 million years ago, their roots were doing something no roots had done before, breaking bedrock apart at a continental scale. Deep root systems pulled nutrients out of that broken rock and into rivers fast enough to trigger algae blooms off nearby coastlines. When those blooms died and rotted, decomposition drained oxygen from coastal waters faster than it could ever return. Picture standing at a river mouth that season, watching the water turn the same thick green you might have seen coat a local pond after a heavy rain, except it stretched along entire coastlines and turned lifeless within weeks. The damage came in pulses, not one single blow. A second wave striking millions of years after the first, and together they wiped out close to 7 in 10 species living in the ocean. For a long time, paleontologists suspected a wandering asteroid nobody could find, Then geologists matched layers of fossilized root systems and algae debris to the exact timing of the extinction, and the culprit turned out to have been growing out of the ground the whole time. The Great Dying. 2 million years is a strange length of time for a single event, but that's how long the eruptions in what is now Siberia kept going, starting around 252 million years ago, right at the end of the Permian period. Non-stop eruption pumped carbon dioxide and sulfur into the atmosphere without pause, and the result reached everywhere at once. Temperature spiked, the oceans turned corrosive enough to dissolve shells, and oxygen drained out of seawater across nearly the entire planet, closing off almost every escape route life had left. Walk that coastline and nearly every animal familiar from a museum display is already gone, leaving only stubborn survivors clinging to scraps of breathable water. The eruption zone alone grew larger than Texas, California, and Montana combined, still glowing red for the full 2 million years. 9 or more out of every 10 species in the ocean vanished, and complex reefs took longer to recover afterward than the entire span of the dinosaurs, from their rise to their own extinction twice over. For decades, this collapse had no confirmed cause. Blamed loosely on climate shifts nobody could pin to a source. Then, radiometric dating lined up the timing of the Siberian eruptions with the extinction almost exactly, and the mystery collapsed into a single, glowing answer. Lava splits a supercontinent. Pangaea was already tearing itself apart when the lava found the crack. Around 201 million years ago at the close of the Triassic period, rifting had stretched the crust of Pangaea, the single landmass holding Earth's continents together, thin along a line that would one day become the Atlantic Ocean. Magma broke through in eruptions across territory that would eventually split into 4 separate continents, and the carbon dioxide it released swung temperatures hard enough to collapse food chains on land and at sea within a span short by geological standards. In some basins, the lava piled up thick enough to bury a 20-story building, layer stacked on layer. Cross that landscape and you'd walk through cracks in the crust venting ash and gas, on ground that hadn't yet decided which future continent it belonged to. Species that had dominated for tens of millions of years disappeared within roughly 10,000 years, taking close to 3 out of every 4 species with them. The extinction that closed out the Triassic cleared almost every large competitor off the board. What crawled into that empty space were small, forgettable reptiles nobody had paid much attention to before. Within a few million years, their descendants were dinosaurs, inheriting a world this eruption had just emptied out for them. Earth runs a fever. Every large swing in Earth's temperature leaves fingerprints somewhere in the rock, and one of the clearest sits right at the boundary between the Paleocene and Eocene epochs, about 56 million years ago. A massive pulse of carbon, likely released from volcanic activity and thawing methane deposits, entered the atmosphere over just a few thousand years. Greenhouse gases, gases that trap heat instead of letting it escape into space, built up faster than the oceans could absorb them, so global temperatures climbed several degrees within a geological instant and stayed there for over 100,000 years. Spend a summer in that world and it would feel like the worst heat wave you remember from childhood, except it never breaks, and it follows you into the next decade and the one after that. Ocean life, built for cooler, more stable water, paid the price first, vanishing from the fossil record in step with the rising heat. Coral reefs shifted. The tropics crept toward the poles. Geologists study this period closely today for one blunt reason. It remains the closest natural comparison on record to how fast carbon is entering the atmosphere right now. Only this ancient version took thousands of years to build instead of a couple of centuries. The eruption that almost erased us. The winter people were taught to fear during the Cold War had already happened once, without a single warhead. Around 74,000 years ago, a volcano on the island of Sumatra, in what is now Indonesia, erupted with enough force to be measured on a scale usually reserved for asteroid impacts. Ash and sulfur reached high enough into the sky to drift around the entire planet, dimming sunlight for years, so temperatures dropped sharply and plant life, the base of nearly every food chain on land, struggled to survive the sudden cold. Anywhere on the planet that year, you'd have looked up at a sky the color of old newspaper, with ash settling on rooftops thousands of miles from the mountain that produced it. Some scientists believe the cold snap that followed squeezed the entire human population down to a small handful of survivors, based on how little genetic variation shows up in people today. That theory is still debated, and other evidence suggests our ancestors made it through in larger numbers. The ash is beyond dispute. It's still sitting in ice cores and ocean sediment on nearly every continent, a fingerprint from one mountain that reached the whole planet. The air itself turned to poison. Nothing alive could breathe oxygen yet. 2.4 billion years ago, that was about to become the problem. Newly evolved microbes called cyanobacteria had figured out how to turn sunlight into energy through photosynthesis, and they began releasing oxygen as a waste product. Almost every other form of life at the time had evolved to survive without oxygen at all, so that waste product built up into a toxin the planet had never dealt with before, wiping out huge stretches of the microbial life that had ruled Earth for over 1 billion years. Stand at the edge of one of those ancient oceans, and you wouldn't be able to breathe the air even if you tried. To nearly everything alive back then, oxygen worked less like a gas and more like bleach. The buildup didn't stop at poisoning the water. It stripped so much methane, a greenhouse gas, out of the atmosphere that temperatures collapsed, triggering an ice age some estimates stretch across hundreds of millions of years. The organisms that caused it adapted around their own waste instead of collapsing under it, and so did nearly everything that came after them, including you. The oxygen filling your lungs right now started out as the deadliest pollutant this planet had ever produced. Which of these 9 collapses surprised you the most? Tell us below and subscribe to see which world gets rebuilt next.